what we're looking at in this lesson is, again, angular momentum and how it is torque affects the rate of change or the change in the angular momentum. But in this example, as opposed to our gyroscope that we looked at, there are no external torques. So everything is going to be internal. And if there are no external torques, then dl dt equals 0, and we have conservation of angular momentum. So L initial has to equal L final. Now, we are limiting our analysis window a little bit because clearly we would need an external torque to get the wheel started. So what we are considering is, as it says here in the notation, that we're picking up our analysis after an external force and torque has rotated the wheel, so that the man in this case sitting on the stool that is free to spin is just holding on to the wheel. So the wheel is spinning, but he is not spinning. The only angular momentum in the system is the angular momentum up. Now, what we're looking at is the situation when he lets the wheel reverse direction. So he's going to simply take it and swing it to his left or to his right to point the wheel down so that the rotation of the wheel, as we see here, I can zoom in a little bit, we can see the rotation of the wheel that gives us, again, with our right-hand rule, spin the fingers, make a fist, the thumb points up. When we do that and he reverses the wheel, now the wheel continues to spin in the same direction, but the angular momentum is down. So he hasn't touched the wheel, he simply reversed the direction, which puts the angular momentum of the wheel now down. And what you want to focus on with the spinning wheel, this type of problem, which would most likely appear in a multiple choice type question relative to different options of what can happen when the person changes what the bicycle wheel is doing, is to focus on the angular momentum vector. Now, in this case, I think it's a little easier, and you can see there's no math involved here because we're locked in. The angular momentum vector can't change without the external torque. So please make sure you get this bit in here into your notes. The fact that we have no external torques, that initial angular momentum is locked in, it can't change. So that means that the two angular momenta that we have over here, namely what the man is going to do sitting on the stool that can swivel, and the wheel, is that both of these have to add up as vectors to give us our initial angular momentum. So when he flips that angular momentum L initial, when he flips it down, action-reaction is going to kick in, and the man is going to rotate such that he's going to generate an angular momentum L up so that those two together will equal the initial. And please do make a note here, because they do love this concept, that it does not matter whether he flips it down by rotating the wheel to his left and lets it fall down, or whether he lets the wheel fall to the right and lets it fall down. It simply does not matter. He will rotate in the same direction to conserve angular momentum. Now, the other version of this question, same idea, same exact idea, is if we start with the wheel in just a different orientation. So now we're starting with the wheel. Now the woman, she got cut off here a little bit in this picture, but we're assuming she is standing on a platform that can rotate, that is free to rotate. But again, she is starting with the wheel in a position where an external force and torque has spun the wheel, so she is not moving at all. And the only angular momentum in the system is this angular momentum to the right based on the omega initial, so get that in there, the wheel rotating in this direction. So if she takes that L vector, so if she pushes down with her hand, right, and lets the wheel tilt, then she has generated an L down, right? She's taken that L vector, and now there's a component of it pointing down, which means action-reaction kicks in, and she is going to rotate to give that angular momentum up, so that the angular momentum up and the angular momentum down will cancel each other out, and we're locked in on just that L initial. But what we would see is that standing on that rotating platform, she would begin to rotate in this direction. So think about what would happen if she raised her right hand, in other words, pushed down with her left hand, raised the right hand, and we can talk about that in class. Again, multiple choice question, this type of situation has appeared, but if you focus on the fact that there's no external torque in this problem, we're locked into the angular momentum, and that no matter what, if the L initial is changed, nature is going to require another L to enter into the problem to balance off, so that the L initial has to go back to remaining unchanged. So there you have it. We'll talk about this again in class. We definitely have some videos to look at that can show us this demonstration as well. And we'll talk about different variations.